China, Russia, North Korea, and all other aspirant nations are ruthlessly aiming at the US. They all lack something that the US does, though: a sixth-generation fighter that is the most technologically advanced ever. Today we will talk about the US $300 billion's sixth-generation fighter jet is finally here. Before we reveal some crazy facts about it, make sure you subscribe to our channel and like this video. Let's begin. With an avionics system that allows it to detect targets on the other side of the world, and an armament suite that allows it to attack those targets, this $300+ million fighter would put a stop to any conflict directed at the US before it even had a chance to start. Additionally, it has a stealth suite that allows it to remain undetected. The world is probably not ready for the aeronautical revolution that this new fighter represents. Aviation Revolution. The initiative known as Next Generation Air Superiority, or NGAD for short, will create the fighter that will assure American air superiority in the future, much like the F-22 Raptor has done so admirably for decades. The elongated blended fuselage of the new NGAD fighter, which fully defies the laws of physics, will make it sleek and aerodynamic. 3 revolutionary technical advancements, as well as ESA radar stealth and adaptive cycle engines, will be housed inside its fuselage. ESA radar. In addition, the NGAD program involves creating brand new, cutting-edge active electronically scanned array radars that will power the fighter's all-kill capability. ESA radars, also known as active electronically scanned arrays, provide several advantages over earlier generations of radar. They eliminate the requirement for quick mechanical scans in various directions, because they don't have the numerous cumbersome moving parts of their forerunners. They are far more dependable, and in certain cases, smaller and lighter. They are capable of scanning vast expanses of the planet's surface, as well as its airspace at breakneck speeds, while keeping track of several targets with absolute accuracy. High sensing resolutions, resistance to electronic warfare attacks, improved performance against stealthy targets, and being themselves stealthy or even greater performance complement these skills. The standard radar mount will be replaced by more cutting-edge electronic smart skins built into the fuselage of the NGAD fighter instead. By combining the tasks of the sensor, electronic warfare, and communication systems into a single multimode ESA arrays, rather than numerous systems each doing one thing at a time, radars may now provide a level of sensor fusion that has never been seen before. Incredibly quick circular coverage, precise narrow beam and wideband capabilities, very high power electronic warfare data, and identification of friends and enemies. The information from each individual function is integrated to create a tactical godlike vision of the battle space that is seamless in detail. It would be simpler to upgrade the aircraft system, both in terms of software and hardware, if it used such self-sufficient ESA radars. Additionally, testing and certifying the various functions may be sped up, if not significantly. The Air Force has promoted the NGAD program as one that will give rise to a whole family of systems, including to man sixth-generation fighter radars, unmanned jets, and other things. Should the radar family on the manned and unmanned fighters be the same? This would not only allow for much more seamless integration and significant economies of scale, but might also be helpful for maintainers working in the field, because they share replacement parts and units, and there are fewer system types overall to maintain. It would be possible to simplify and group essential maintenance chores. Core software updates would also be easier to complete one at a time. It's crucial to understand the advantages of this level of sensor fusion, the amazing American talent working on the NGAD program, and the fact that it is still a delicate idea that requires skilled hands and brains to carry off. It won't be long before it is accomplished. Stealth. Stealth is a set of measures that prevents enemy soldiers and radar waves from spying on a 20-ton fighter as it flies above them silently. The NGAD fighter will use this groundbreaking technology. No fighter needs lower its radar cross-section, infrared signature, or sound signature to be stealthy. The NGAD fighter's specific strategy is locked in a chest at the bottom of the ocean, but calculated assumptions and expectations can be formed. Radar cross-section measures how much radar radiation an object reflects back to the source. If the source receives a lot of radar energy, it knows there's an airplane. To prevent being shot down, and aircraft must reflect little radar energy. The NGAD fighter's smooth, angular surfaces scatter radar waves away from the source rather than reflecting them. The fighter will have no vertical stabilizers to reduce reflections. It's the first fighter with this design. Additionally, the fighter will be covered in materials that absorb or deflect radar emissions as opposed to reflecting them. The aircraft's engines and exhausts are cooled to limit heat emission in order to lessen the fighter's infrared signal. These cooling systems share the same genetic makeup as the North Pole. To dissipate the heat by transferring it to other areas of the aircraft or to the surrounding air, heat sinks or exchangers are also used. In addition to being cooled, the fighter's exhausts and engines are now hidden from the infrared sensor's direct line of sight. Finally, the sound signature must be minimized. Simply put, acoustic signature is a way to quantify how much sound a thing makes. The NGAD fighter must operate in complete silence. One engine noise, one engine hiccup, or one YouTube channel subscription might mean the difference between a mission success and a run-in with a surface-to-air missile. To minimize the acoustic signature, engines, propellers, or fans, as well as other technologies designed expressly for noise cancellation, noise masking, and other noise reduction operations, must be installed in the NGAD fighter. The fighter will be able to enter anti-access areas covertly, dance for a while, and then launch its mission engine thanks to all of these and more. The NGAP program, which stands for Next Generation Adaptive Propulsion, is now working on the engine that will power the NGAD fighter. GAD is a vast subprogram of NGAP that is searching for a groundbreaking jet engine. So groundbreaking in fact that Pratt & Whitney, General Electric, Boeing, Lockheed Martin, and Northrop Grumman have each received roughly $3 billion in contracts. Given that the last three are the most likely makers of the NGAD fighter, and that they haven't even traditionally built engines, awarding them engine contracts could lead to a completely novel approach to airframe engine integration. According to reports, the new NGAP engine would be an adaptive cycle engine that allows the fighter to switch between more speed and more range at will. This level of versatility has never been seen before, but it was still predicted. It is known that concepts for adaptive cycle engines were created with this in mind. The term variable cycle engines is sometimes used. These jet engines are appropriate for next-generation military aircraft and supersonic transport because they are built to function effectively at subsonic, transonic, and supersonic speeds. They have the ability to switch between high-thrust and high-efficiency modes, allowing them to adjust to various flight circumstances and select between traveling further at a quicker speed or the ideal combination of both. With adaptive cycle engines, the fighter can have the best of both worlds instead of the configuration that designers would typically have to settle on. Today's adaptive cycle engines are constructed employing a three-stream architecture in which a third bypass stream can be employed to boost the bypass ratio when fuel efficiency is needed, or to deliver more airflow to the core when more power is needed. This idea is utilized in the engines created by NGAP. Thus, when they go into service, they will represent the biggest jet engine upgrade in the history of the United States. Along with a vast array of kinetic and laser-directed energy weaponry, new adaptive radar systems, tailless stealth designs, and adaptive cycle engines are all in development. An NGAD fighter that is stealthy, agile, intelligent, and leaves low enough to go undetected and unstoppable is what all the evidence points to. The surface's air dominance plan for the future revolves around 200 NGAD fighters flying in tandem with 300. According to information provided by the Air Force through its Secretary Lieutenant Colonel Frank Kendall, the combined 505th and 6th generation warplanes of the F-35 Lightning II will be used as unmanned loyal wingmen during missions. The NGAD program has already cost over $4.2 billion, and between the fiscal years 2024 and 2027, another $11.7 billion, as well as at least another $40 billion will be spent on it. To replace the present top air superiority fighter in the world, the resulting aircraft will start entering service in the 2030s. The sixth generation of fighter jets is finally here, and to enable them to deliver on this promise, they vowed to be the most fascinating, most unusual, and all-around jaw-dropping pieces of military technology these folks have seen in a long time. What do you think about this? Please tell us in the comments. Subscribe to this channel and give a thumbs up on the video.